On the 17th of September 2007, the contract was signed for implementation of the new safe confinement project, focused on the transformation of the shelter object into environmentally safe system. Physical activities under the project began in the future assembly area of the new safe confinement with the demolition of separate buildings and structures, and upper soil layer was removed to improve the radiation situation at the territory. 158,000 cubic meters of processed materials and radioactive waste were removed from the site and disposed. Clean soil was then delivered at the territory of the future assembly site for backfilling. The work has been performed under difficult radiation conditions. The construction of the NSC erection area and arch sliding area foundations began at the prepared site. Foundation works were undertaken in the trenches simultaneously with the preparation of the sites for construction of lifting towers. Special clean routes were laid to ensure efficiency and safety of transport operations. These roads provided access to the assembly area for heavy equipment. Only thereafter it became possible to begin concrete works, placement of blinding concrete at the site, installation of the reinforcement cage manufactured outside the site, and finally casting of structural concrete. Sliding rails were built with deep foundations to support the weight of the arch. For this purpose, 720 metal piles, 30 meters in length, were driven in soil. 137,000 cubic meters of concrete were casted for the construction of the arch side, 57,000 square meters in area. Segments of the arch sections were manufactured in advance outside the assembly area. The weight of one segment ranges from 120 to 400 tons. Its height equals to a 4-story building. The segments were transported to the assembly area with the help of heavy lift load platforms. The arch consists of two parts, the east half and the west half. The first to be assembled was the east half. The relevant elements were interconnected with bracing to ensure stability of the structure. The first assembly towers were erected and installed on the edge of the upper segments. The side segments were then transported to the assembly area and connected to the top segments using a hinge system. This hinge structure was lifted with the help of lifting towers in order for the side segments to take their operating position. This procedure was applied to implement the first and subsequent arch lifting operations. On completion of each lifting operation, the lifting towers were moved aside and adapted in a new position to continue the assembly of side segments and their further lifting. After each lifting operation, the connected segments were rigidly fixed. In total, 3 lifting operations have been implemented for the east half of the arch. Dismantling of the ventilation stack shared by units 3 and 4 was performed in parallel with the construction of the arch. A new ventilation stack of the ChNPP second generation was constructed prior to dismantling with a view to ensure technical operations. For optimization of the process, the assembly of the west half began on completion of the third lifting operation for the east half of the arch, in parallel with fitting the cladding and equipping the east half. Thus, the second half of the arch, the west one, was being placed under the east part of the arch until the first lifting operation. When the east half was completely assembled, the pushing equipment moved into place to slide this half into its waiting position. Just in 3 weeks after this event, the first lifting operation for the arch west half was performed. The west half of the arch was then assembled in the same way. Once the west half of the arch has been completed, the east half has been moved back to the assembly area to connect two halves of the arch. At the next stage, all the arch systems have been integrated and equipment has been assembled. The assembled systems are as follows: systems of main cranes, air ducts and radiation safety monitoring, seismic control, ventilation and water supply systems, drainage, power supply and fire safety systems, physical protection, communications and industrial TV systems, radioactive waste and fuel containing masses management systems. In parallel, the work was underway towards the implementation of an important project, construction of end walls of the new safe confinement. A significant part of this work has been implemented under conditions of high radiation exposure inside the shelter object. Construction works included the creation of external and underground engineering networks, auxiliary and technical buildings and structures. In November 2016, the arch, which by that time weighed more than 36,000 tons, was moved along 320-meter rails into its designed position over the shelter object. Completion of the project and commissioning of the new safe confinement is scheduled for 2017.